Today, I want to talk about a transformation called a reflection. Now, we've heard reflections mentioned in the real world, just like when we look in the mirror, we see our reflection. Oftentimes, when we look in the mirror, our image is flipped. So, for instance, if I'm looking in the mirror, I part my hair on the right. However, my image shows that my hair is parted on the left. So a good way to remember your reflection, or the reflection, is to think of it as a flip. So if we are looking at number 1, and we're looking at this image, and we want to see if it is a reflection, if we were to draw a line, maybe that symbolized a mirror, we would want to know if we took this and we flipped it, would it be the same image flipped? Here, as you can see, this triangle, when we flip it over this line, would be the same. So we would say, yes, this is a reflection. Then, if we're looking at number 2, we want to see if there's any way, if there's a line that we could draw between the two where this could flip and be the same image. If we flipped this over, there's no way that it could make that same shape and be facing the same way. If we look at the points actually and look at how far they traveled, we would see that this is actually a translation. So here we would write no. Then, looking at number 3, if I was to draw my mirror or my line between the two, we would want to know if this shape, this frown, could be flipped and make a smile. And obviously we know, we joke about that all the time, we flip that frown upside down and get a smile. So yes, this would be a reflection. Now, let's look at it on the coordinate plane. So first off, we want to list the points of triangle ABC. So looking at A, those points are -2, 1. B would be 3, 1. And C would be 2, 5. Now, they want us to list the reflection. It was reflected across the x-axis. So they want us to list those points now. So looking at A, if we count A prime, now would be -2, -1. B would be 3, -1. And C would be 2, -5. So now, looking at each set of points, what do you notice changes in each one? In each one, the y value becomes negative. So the rule that you will notice is that our x stays the same, y becomes negative, or changes sign. If we look back up at number 1, we could look at this as our y-axis, right? Because it's going up and down. So over here, this flips over the y, and then here, if we think of this horizontal line as the x-axis, this flips over the x-axis. So in number 2, it would flip the same way as in number 1. So let's talk about if we were reflecting over the y equals x axis. So this one looks a little bit different. In this one, if we list our points here, our A is 2, 4. Our B is -1, 4. And our C is -3, -1. Now let's list our A prime, B prime, and C prime and see the correlation there. So looking at A prime, we would be at 4, 2. At B, I would be at 4, -1. And C would be -1, -3. So now compare your A prime, B prime, and C prime, and tell me what you notice about each. So after looking at all three of these, we see that each time our X and Y swaps. And so the rule that we notice here is that X and Y would swap positions. So it would be Y and X. Now, I want to talk about the rule for Y equals -X. Okay? So we knew the rule for Y equals X was swapping Y and X. What do you think this negative may do to the points? So let's say we have points -2, 2, 1, 2, and -1, 4. So we know if we were doing it across the line Y equals X, we would flip the X and the Y, so it would become 2 and -2. B prime would be 2, 1, and C prime would be 4, -1. Now, if we applied this negative here, that would actually change the signs. So this would become negative, this would become positive. Our 2 here would become negative, our 1 here would become negative, 4 would become negative, 1 would become positive. So it's the same thing as Y equals X, yet we add a negative, or we change the sign of each one. So let's try an example. There's your rules for reference right up here. So let's look at number 1 here. They want us to reflect the figure with the given vertices across the given line. And state the coordinate of the image. So here we have A, B, and C that they want us to reflect across the y-axis. So reflecting across the y-axis means that our x, or the sign of our x, changes. So here I would write A prime, B prime, and C prime. Here our y would stay the same, so I'm going to go ahead and write 5, 2, and -1. Now, when I go back and look at my x's, all of these signs are going to change. So this would change from a -7 to a +7. This would change from a +1 to a -1, and this would change from a +3 to a -3. And there you go. we reflect it across the y-axis. Now, let's try y equals x. Remember, if y equals x, our x and y values change. So I would write j prime, k prime, l prime, and m prime. So here, we're going to swap these. So this would be -2, -4. We swap our x and y here. That would give us 6, 3, 4, -1, and -3, -2. Alright, now let's try one on the coordinate plane. So let's look at 7. In number 7, they want us to graph the pre-image. Remember, that's this, the first set, and then they want us to graph the image, which is our prime. So let's go ahead and write out our prime here. They want us to reflect across the x-axis. So that means our y's will change. So here I would keep 2, change the sign of 1. For b prime, I would keep -4, change the sign of -3, so that would be a +3. And for c prime, I would keep 3, swap to -2.